So we have finally arrived at the last type of carboxylic acid derivative. That's nitriles. We've got one to name, and then we're moving on to reactions. This guy has 2 carbons, so the common name of the acid would be acetic acid. I hope you know that by now. So it becomes acetonitrile, common name. It's ethanoic acid, IUPAC, so it becomes ethane nitrile. Whether the O is included or not, just sort of what sounds better. All right, on to reactions. There are 3 ways that we can make nitriles, since we haven't talked about making those yet. That's these 3 ways. We're going to walk through these 3 examples. The first one is nucleophilic substitution. I hope you recognize that that guy is a tosylate. That's a sulfonate ester kind, a sulfonate ester variety. So when you add cyanide to that tosylate, what kind of tosylate is it? Primary. So tosylates are sulfonate esters. They follow the flow chart. Primary says SAN2. Note we started with 1, 2, 3, 4, 5 carbons. My cyanide added a new carbon, so I've now got a 6-carbon nitrile thing. Remember, a tosyl has an abbreviation as well. It could have said OTS. That's tosyl. Primary tosyl. Gonna make the same product up there. We're gonna move on to the next example without going back to the PowerPoint. This one is not a reaction type that we've seen before, but it's the next type of reaction that we will study. This is an aldehyde reacting with cyanide and acid. Aldehydes and ketones are class 2 derivatives. Class 2 derivatives do not do substitutions, they do additions. Attack the carbonyl carbon. We've seen that a time or two. Protonate the O minus you just made. This is called a cyanohydrin. A single carbon has a cyanide and an OH on it. It's a cyanohydrin. So a couple of slides ago, we said there were 3 ways to prepare cyanides, 3 ways to prepare nitriles. You've now seen 2 of them. The third way is actually a repeat of something we studied in the amide video. You can dehydrate an amide to make a nitrile. Remember, P2O5 is a dehydrating agent. You're going to lose the 2 H's and the O off of your amide. Remember, it has to be a special amide that has 2 H's here and an O to get rid of. You're dehydrating, losing water. So 3 ways to make nitriles. Once you make them, one of the reactions they do is they can be hydrolyzed. As we have said time and time again, all carboxylic acid derivatives can be hydrolyzed to form carboxylic acids. Let's do it. We'll hydrolyze that nitrile next to a benzene, but we could hydrolyze any, really. We're going to hydrolyze under acidic conditions using acid and water. First thing you do, protonate the carbonyl oxygen. Wait, what? Yeah, this is our stand-in for a carbonyl. It has similar characteristics. So we're going to protonate that carbonyl oxygen. Sorry. Protonate that nitrogen, just like we do the carbonyl oxygen. And then your nucleophile attacks the carbonyl carbon. Yeah, I know, I'm not losing my mind. It's not a carbonyl. What's our goal here? We're trying to make a carboxylic acid. So that tells me we want to keep this O, we want to get rid of the nitrogen, and we actually want to add an additional O. So we're going to do a little intramolecular exchanging of protons. Is it truly happening intramolecularly? Not likely. It's probably between two different molecules, but we'll take shortcuts when we can. Now I've got a protonated nitrogen that makes this carbon more partially positive, so water attacks the carbonyl carbon again. Remember, we're trying to make a carboxylic acid, so we need two O's connected, and we need to get rid of the nitrogen that's connected. I could do another intramolecular, but from here, I'm going to be consistent with the way we've been doing mechanisms for all these other derivatives. Some base comes to clean up. And this is my neutral tetrahedral intermediate. Neutral tetrahedral intermediate. So I'm ready to fold down and kick out? No, not quite. Because this whole reaction is happening in acid, I need to protonate my leaving group before he leaves. The nitrogen is the thing that has to go because I'm trying to make a carboxylic acid. And then I fold down and kick out my nitrogen. I'm going to sit it up now just to make it more pretty. And I kicked out NH3, ammonia, which is a base. So that's my base that cleans up this final hydrogen to give me, ta-da, carboxylic acid and NH4 plus. Nitrile hydrolysis. Nitrile is the least reactive derivative, so it does the fewest reactions. Hydrolysis is it. Hooray! Let's do a couple of fill-in-the-blank things. That top little reaction, we've got NABR, acid, and an alkene. What's the very first reaction you learned in organic way back when? Reactions of alkenes. That alkene is going to get protonated to make a carbocation here, benzylic and secondary, and HSO4 minus, the conjugate base of this guy, not a good nucleophile, but bromide is a good nucleophile, so bromide attacks the carbocation. There you go. You have an alkyl halide, a secondary benzylic alkyl halide, secondary anions, yes. Strong base, no. Therefore, SN2. Done. And then H3O plus should really specify H3O plus water heat. You probably do need to heat to be able to hydrolyze a cyanide. Yep, we're hydrolyzing. But wait, where did that extra carbon come from? What extra carbon? This one. This is what was your cyanide carbon. So we started out with an 8 carbon molecule, ended up with a 9 carbon molecule because the cyanide brought an extra carbon to the party. Another one, sodium cyanide, acid, and an aldehyde or a ketone. You're going to attack the carbonyl carbon, protonate it, and it's done. It does addition. Class 2 does addition rather than substitution most of the time. Attack, make a cyanohydrin like this. And then we've got 2 pathways down here that look kind of similar. This one is acid and water. This one is H2SO4. This one is trying to specify that no water is present. This one is going to do hydrolysis of your cyanide, like so. This one is going to actually dehydrate your alcohol. like so. So be careful, the conditions are similar. They're both acid, but one is acid with water, the other is acid in the absence of water. One more set of things. The Gabriel synthesis of amines. Let's write a little bit about this one. The Gabriel synthesis. It's a way to make a primary amine. You may not remember as well as I wish you would, but back a long time ago, the beginning of this semester actually, we talked about it's difficult to synthesize a primary amine through what you would maybe think of as traditional methods, like SN2 on an alkyl halide. It's difficult to turn an alkyl halide thing into a primary amine, like this down here. Because what happens is amines are bases, it's going to deprotonate, it will attack again and again and again and again. So you get mixtures of primary amines or ammoniums, secondary amines or ammoniums, tertiary amines or ammoniums, and even quaternary amines or ammoniums. So if you're trying to synthesize a primary amine, this is really kind of a traditional thought process based on what we've learned, but it doesn't work really well. The Gabriel synthesis is a way that does work well. It starts off by deprotonating this nitrogen, this imide nitrogen. Deprotonate. And then you add a good SN2 substrate. This could be a halogen, this could be a sulfonate ester, something like that. SN2. It's a primary alkyl halide. SN2. It brought along 3 carbons, 3 carbons, 3 carbons. And then this says hydrolysis or NH2, NH2. We're going to do hydrolysis, but we're going to do hydrolysis like this. Hydroxide water heat, hydrolysis. What's going to happen with hydroxide water heat? It's going to chop that bond and that bond to make this. Chop those 2 bonds. The carbonyl side becomes a carboxylic acid, except we're hydrolyzing in base, it becomes a carboxylate. It becomes a carboxylate. The nitrogen gets protonated to become neutral, not positive, not ammonium. It's an amine because we're hydrolyzing in base. How would this be different if we had hydrolyzed in acid? If acid, you better know that that nitrogen is going to be an ammonium. And those carboxylates are going to become carboxylic acids. Acids and bases will kick your butt this time if you let them. Don't let them. That's all for now. Peace out, yo.